Imagine gazing into the depths of the universe and feeling, deep in your bones, that something out there is gazing right back. That unsettling, awe-inspiring sensation is exactly what scientists experienced when the James Webb Space Telescope, the most powerful observational tool humanity has ever sent into orbit, detected something completely unexpected. This wasn't a routine find, no distant galaxy or dazzling nebula for NASA's archives. Instead, Webb captured signals, patterns, and anomalies that seemed to defy everything we thought we knew about space. Initially, the data appeared random. But the closer scientists looked, the more it all seemed intentional, structured, and, perhaps, whisper it, intelligent. For generations, we assumed the universe was cold and indifferent, a vast and silent expanse ruled by physics and randomness. But what if that assumption was wrong? What if, buried in the quiet darkness of space, there were messages, patterns meant to go unseen? Messages we were never supposed to find. Today, we explore the latest findings from the James Webb Space Telescope, data so unprecedented that it's forcing astronomers to ask questions once thought to belong only to science fiction. Are we really alone? It all began not light years away, but right here in our own solar system. Webb turned its senses toward Neptune, one of the frozen giants orbiting at the outermost edge, a planet long believed to be static, unchanged for eons. But what Webb saw shattered decades of accepted science. Compared to data from Voyager 2's flyby in 1989 and more recent Earth-based readings, Neptune's upper atmosphere had cooled significantly, by nearly 10 degrees Celsius, within just the last few decades. No solar cycle, no known internal process, could explain this dramatic drop. Adding to the mystery, Webb detected strange fluctuations in Neptune's magnetosphere, subtle yet measurable, like an unseen pulse, steady and rhythmic, emanating from within. Was this the result of an external force? Perhaps a passing gravitational wave, a distortion in dark matter density, or something stranger still, an influence stretching across space, subtle enough to go unnoticed until now. The mystery had only just begun. As the Neptune data stirred unease, Webb set its gaze on the TRAPPIST-1 system, a stellar neighborhood just 39 light-years from Earth, already famous for its 7 rocky planets, 3 of which lie in the habitable zone. TRAPPIST-1 has long been a tantalizing candidate in the search for life. But Webb's instruments didn't just confirm what we already suspected. They revealed something far more profound. Through detailed infrared spectroscopy, Webb detected the distinct chemical signature of water vapor in the atmospheres of 2 of these planets, TRAPPIST-1d and TRAPPIST-1e. And these weren't faint traces. The data suggested dense, humid atmospheres, perhaps even thick with clouds, not unlike those on Earth. With the planet's stable orbits and temperature profiles, the most plausible explanation is the existence of deep global oceans, ancient, stable, and potentially life-sustaining. Even more startling was the presence of compounds similar to ozone and molecules that, on Earth, are intricately tied to biological processes. While this doesn't confirm life, it's the closest we've come to finding a true Earth analog, not once, but twice, in the same system. But Webb's ambitions didn't stop there. In one of its deepest sky surveys, it locked onto a galaxy called JADES GSZ 13-0, one of the earliest ever observed, its light born just 330 million years after the Big Bang. Yet the real shock wasn't that the galaxy existed. It was the type of radiation it emitted, specifically strong Lyman-alpha emissions, which should have been absorbed by the neutral hydrogen that filled the early universe. But these emissions were somehow passing through, clearly unimpeded. This shouldn't be possible, unless that hydrogen had already been ionized well before the cosmic timeline would suggest. That raises the question, what ionized it? Could some unknown process, natural or even artificial, have accelerated the transformation of the early universe? Some researchers have dared to wonder, is this evidence of galactic-scale engineering? Or an unknown energy phenomenon that defies every current model of cosmic evolution? It's no longer just a question of what happened. Now we must ask why, and who. Webb didn't just explore ancient galaxies. It also peered into the hushed aftermaths of stellar death. One particular system, WD 0856+534, should have been unremarkable, a white dwarf surrounded by the remnants of its former solar system. But instead of silence, Webb found something that shouldn't be there. A massive gas planet orbiting close to the dead star, surviving what should have been a cataclysmic stellar collapse. What's more, the planet's atmosphere showed signs of regeneration, traces of water vapor, sulfur compounds, chemicals that suggest the planet is adapting, continuing to evolve even in the dying light of its host. This challenges everything we thought we knew about habitability. If a planet can survive the death of its star, might life be able to as well? Could ecosystems, even civilizations, arise or persist in these twilight systems, drawing power from heat, magnetic flux, or unknown energy sources? Where we once saw cosmic tombstones, we may now be looking at cradles of resilience, or something even stranger. Closer to home, Webb turned its instruments toward the overlooked moons of Neptune and Uranus. Previously dismissed as cold, dormant rocks, these satellites surprised researchers. Tiny irregular moons like Hippocamp and Despina showed unexpected thermal signatures, readings that suggested active geology or even cryovolcanism beneath their icy crusts. More intriguingly, Webb detected complex carbon-based compounds on their surfaces, possible building blocks of life. These tiny moons shouldn't have the energy to remain active for billions of years. Some have proposed tidal heating or radioactive decay as possible explanations, but neither accounts for the chemical complexity or organizational patterns found. Which raises a bold alternative: external seeding. Could these moons have been visited or altered long ago? And then came the most haunting discovery yet. From a galaxy astronomers have studied for decades, Messier 82, the cigar galaxy, known for its rampant star formation and energetic environment, Webb uncovered a new signal. An infrared pulse, repeating at fixed intervals, originating from the galaxy's core. It wasn't background noise or random interference. It had structure, rhythm, precision. Some astronomers have quietly compared it to the templates used by SETI to search for intelligent broadcasts. Natural causes like pulsars or spinning neutron stars remain on the table. But so far, no known process in the visible or X-ray spectrum matches this pattern. Which means we might be witnessing the fading remnants of a signal, one not meant for us, but intercepted all the same. Webb then turned to the star known as Tabby's star, once infamous for its strange, unexplained dimming events. Previous theories ranged from comet clouds to debris disks. But Webb's high-resolution observations told a different story. The dimming wasn't caused by dust. Instead, thin, flat, opaque objects appeared to be passing in front of the star at consistent intervals. These objects seemed angular, massive, possibly artificial, and surrounding the star. Webb picked up a strange faint thermal glow, waste heat that didn't match the star's natural output. Was this the footprint of a Dyson swarm? Not a fantasy, but a functioning energy-harvesting megastructure. And then, in the Pandora's cluster, an ancient and chaotic region of space, Webb noticed something else. As it used gravitational lensing to peer at distant galaxies, shadows began crossing one of those far-off light sources repeatedly. These were not camera errors or noise. They were real, physical occultations. Shapes moving in front of the background light. But the things casting these shadows emitted no light, reflected nothing, and remained completely invisible, except for what they blocked. Based on their size, speed, and repetition, some speculate these could be stealth satellites, or, more provocatively, dark, non-reflective megastructures built to avoid detection entirely. What James Webb is revealing isn't just new science. It's something deeper, something that seems almost forbidden. A growing collection of clues, scattered across the cosmos, each whispering the same uneasy idea. What if the universe was never empty? What if we've always been watched? From Neptune's icy moons to the pulsing heart of distant galaxies. From the hidden oceans of TRAPPIST to the silent silhouettes drifting across the cosmos. Webb hasn't just opened a new eye on the universe, it has peeled back a layer we didn't know was there. A veil that might have been placed for a reason. And now, there's no turning back. We stand at the edge of something monumental, a revelation that the cosmos may not just be vast and ancient, but also aware. Listening. Reacting. Perhaps even warning. And the most staggering truth of all? This is only the beginning.